Hey everyone, welcome back to Dev Parkour. In this video, I want to talk about stored cross-site scripting. A couple of weeks ago, I talked about reflected cross-site scripting, which is where you're on a page, you make some change, either enter some information in a form field or change the URL and add some script. And when you submit the request, the response comes back and script executes in the browser. Stored cross-site scripting is very similar. It's still entering some script into either a form field or as part of the browser URL somewhere in a request. But regardless of whether it actually reflects back in the resulting response, that script gets stored in the database somewhere, hence the stored part, allowing it to execute sometime in the future when either the same person or, more often than not, a different user, a legitimate user of the system, visits a page that retrieves that information from the database, and then it executes in their browser. So typically this is used on, let's use the example of like a blog site. A malicious actor might put some script into a comment field. And if they succeed in executing a stored cross-site scripting attack, anyone who views that post will have the script run in their browser. So that means that they could potentially compromise the sessions or the credentials of any user that in the future visits that blog post. So it's a very dangerous attack, and it's one that you really have to watch out for. So in the security scan that I ran a couple months ago, stored cross-site scripting did come up as something that the application was vulnerable to. If you haven't been following along with the channel for the last several months, I've been working on Glassminnow, a PHP application that I wrote several years ago and decided recently to kind of dust off and take from legacy PHP application and bring it into the present and hopefully the future, making it cloud native, making it secure, making it scalable, basically just providing best practices and applying best practices to this application and making several videos out of the process. So we're going to dive into Glassminnow, and we're going to first execute this stored cross-site scripting attack, and then we'll actually fix it. And fixing it is something that's definitely tricky. And I'll explain why that's tricky when we actually get to that point. So let's switch over to Windows Terminal and make sure my development environment is up. So let's see. Doesn't look like it is. Let's go ahead and start the container. Okay, and now it is running on port 49153. So let's make sure that we have that running as well. Looks like it is running. Let's log in. And this particular attack that was found by the security scan is in this messaging section under drip campaigns. I'm sure this sort of vulnerability is present elsewhere in the application, but it's definitely present here. And you can see we're already running into a stored cross-site scripting vulnerability because a script executed on this page. The way that was executed was basically this campaign name field is vulnerable. So if I do 1, 2, 3, 4, and then script, just to be different from the other ones that showed up. And there we go. That's the one I just put in. So obviously that's kind of a reflected version of the attack because we landed on the page that's the result of submitting that form. But if we go back to messaging drip campaigns, we should see, in addition to those other alerts, we should see a new one. Maybe not quite. This page might not be vulnerable, but it does look like there are a bunch of different attacks that the security scan attempted. This one creates what looks like an iframe. If we inspect, yeah, that's an iframe. This one tried some encoded script. This one tried it with just text. Lots of different attacks. So let's fix both this page and let's fix that second page that we just hit when we created the new drip campaign, which should be, looks like 584. So these will be our two test pages. So let me just open that in a new tab. All right, so let's start with drip campaign, and this is actually the index page. So let's cd to our directory, open up Visual Studio Code. And now there are two things, kind of two main ways to defend against stored and also reflected, but especially stored cross-site scripting vulnerabilities. The first is to sanitize inputs when they come into the system. And that's good if there are specific formats that you're expecting. For instance, if you're looking for a phone number, make sure that you have a valid phone number. If you're looking for an email address, make sure you have a valid email address. If you're looking for free text, just basically anything, that can be a little bit tricky because legitimately anything is valid potentially. If you can narrow down the set of inputs that should be valid, then that's a good approach. But by far the better approach is to make sure that anything that you are presenting to the screen or sending down to a client or a browser in this case is something that is valid for the context that it's going to be used in. So in the case of interpolating it into HTML, the way PHP does, we need to make sure that anything that could potentially be interpreted as HTML gets stripped out. So let's go over to, let's start with app views. So it's drip campaign index. And we can see it's basically just a loop for each campaign in the list of campaigns. Echo the ID, that's safe. ID is safe. Name, this is not going to be safe. So let's do HTML special characters. And if you look at the signature here, there are actually a few optional parameters. I'm actually going to use a feature of PHP 8 to go to this double encode parameter. I don't want to set all these other ones, but I do want to set double encode and set that to false. By default, it's true. So that's wrong. False. And I believe I have the syntax correct. Let me check to make sure real quick. Named arguments, double encode, false. Okay, that is correct. My guess is that Visual Studio Code just doesn't support it quite yet. All right, and now while we're here, let's look at some of these other things. Enrolled count, that's a number, converted count, canceled count, converted criteria. All of those are, well, I'm not sure about converted criteria, to be honest. Let's just wrap that just to be on the safe side. All right, so now let's see if that works. So it's this page right, no, that's this page right here. And as you can tell, the page loaded just fine and none of the scripts got executed. And there's the one that we just put in. you'll actually notice that originally this page wasn't even loading all the way to the end. It was getting to a certain point where it was trying to execute script and it was actually stopping the page from loading. But now it is actually loading all 584 drift campaigns. So we could actually just click this link and get right to this page. But you can see that this page is still vulnerable. So let's go fix that. So that would be the show page. And that's right here. So HTML special characters. All right, and there we go. Our vulnerability is fixed. Now, the one downside to this is that because you're fixing it every time you're addressing the vulnerability in every spot where this information is displayed, it does mean that there are potentially a lot of different places that you need to put in that HTML special characters function. So, such is the nature of security vulnerabilities. You don't know where they're going to show up, and you don't know necessarily if they're only going to be in one place or if they're actually going to appear in multiple places. There are potentially ways to get around that, but in the interest of being safe, it's a lot better to have this defense at every possible place where the vulnerability might occur, as opposed to assuming that data is safe at any point along the line, whether it be in the database, in a configuration file, certainly not coming in from a user, and then just assuming that everything that uses that is safe and you don't have to defend against it there. Defend against these vulnerabilities every single spot where they might creep in or where they might become an issue. The other upside to addressing these vulnerabilities where the data is displayed is if the vulnerability was exploited before you had a fix for it somewhere else along the lines, you at least know that you are defending against it in the when it finally gets displayed. So good recommendation across the board. So that's basically that. Like I said, there are plenty of other vulnerabilities like this, I'm sure, in the rest of the app. So off camera, I will make some changes to address those. But for now, that's basically it. That's what we're going to do for this video. If you enjoyed the content, go ahead and hit that like button. Please subscribe to the channel. I really appreciate it. I've gotten a lot of new subscribers over the last several weeks, and I appreciate every one of you. You've left a lot of great comments, asked a lot of great questions, and I look forward to making more and more videos for all of you in response to those questions and in response to just the content that I've been making. I'm really excited about where the channel's going. So if you're not already subscribed, please definitely subscribe so that you can continue to be a part of this journey with me. And if you have a question or a topic that you want me to cover in a future video, please don't be shy about leaving a comment down below. I love reading the comments. I love responding to the comments. And ultimately that's really what makes it all worth it, to see that you guys are learning and benefiting from the content that I'm producing, and engaging with it on a deeper level. This is not just a passive thing, but you're actually getting into it and trying to go further than just what I've presented in each individual video. So I really appreciate that. Go ahead and leave a comment down below, and that's it for today. Thank you for watching, and I will see you all tomorrow.